Okay guys, this is a shot of the English wheel I just finished building. I mentioned it a few times and it's now finished and I've got some time on it and I'm super happy with the results and I just wanted to take you through it. This is a design from a guy named Kirk down in Virginia. We'll talk more about him, but he is the inventor of this newly designed frame, and it's been 15 years in the design, and he built a couple prototypes, and I built mine a little bit heavier than he built his first couple prototypes, but it really paid off. It's super nice. I have it attached, as you can see, to my power hammer, and I had some stock laying around, so I made some big hinges here. I got a pin here. I got a pinch bolt down there, so it can fold up against the power hammer, but there's no legs on it or anything. It's just it's either in this operating position this way or just fold it up to save space. And like I say, it's working flawlessly, and I'll take you through some of the features in just a minute. And let me reset the camera and I'll be right back with you. Okay guys, this is basically been labeled and called the American Wheeling Machine. You could see the inventor, my buddy Kirk, the modeler, and I started this in 2017, finished it up in 2018, and after his prototypes, there's the first machine out there, and it's basically the fourth rendition of this particular design, and it might be hard to understand what's happening until you use a wheel like this, but I'll try and take you through some of the features that make it a very stiff or loose machine, whatever you like. It's super adjustable. You can change the feel of this machine with just little tiny adjustments, and I'll take you through some of those features now. Okay, on my lower adjuster, this is just an Acme screw that does the adjusting, and this is a coarse adjuster here. It's 1 inch 5, I believe, and then when you come up to the top, this is my fine adjuster, and you can see that's still a 1 inch Acme screw, and that does my fine adjustment. Just when I'm creeping up on a panel, I'll start to adjust it. I do a lot of adjusting on the bottom and then just creep up on it with the top adjuster, but that's fine. It can put a tremendous amount of pressure on a panel. You can shape real fast, or you can loosen it up and just wash over a panel. Just depends what you're doing. So bottom is your main coarse adjuster, top is the fine adjuster. Okay everybody, starting at our upper wheel, I'm going to try and show you the flow and how things are going here. So I've got my upper wheel, I've got a adjuster, obviously to adjust that up and down, and what we're calling these are blades. So there's a thrust bearing here, and then this is made out of 3x3 1/4 inch material, a little bit bigger than the originals, but it's what I had in stock. This pressure screw right here is how we load the frame. This will stiffen the frame right up, and it's a little bit bigger. I probably could have went a little bit shorter on this, but this is my first time through. We have a pivot here. I have a grease fitting and a slug in there, and so that gets plenty of grease. And then we're connected with our top and bottom blade here. I've got another grease fitting and a 1 inch bolt through there. I've got some 4x4 3/8 wall material that connects the upper blade to our bottom blade, and same thing here. We've got a pivot point here, another pivot point here. This comes through. I've got another pressure screw here to load the frame, and then we're into our adjuster here, and that comes back up to our lower wheel. And as you can see, there's plenty of adjustment here. By tightening or loosening our blade screws here, we can completely change the feel of the machine. Very soft to very, very hard and rigid. And there's a lot going on here. It's kind of, like I say, it's kind of hard to explain what's happening, but I hope you can see it. And Kirk is, he's offering some plans. It's a very big project. It is time consuming. You need a lot of tools, machine work. You need a lathe. You need a mill, and it just takes a lot of time. I put this together probably over 8 months, and there's a lot of machining. I had to make my own anvils, my upper wheel, my lower anvil. I was not happy with anything that was out on the market, and these took quite a bit of time to make because I don't have any CNC equipment. But they're on there. I've got that upper wheel within 2/10 run out, and the lower wheel's the same thing. That's it's about half a thousandth run out on the wheel. So take your time, make your wheels right, and it'll be much better. As you can see in here, I have my lower cradle attached with a 3/4 bolt, and I've got Allen screws in there so I could tilt this and adjust this in any direction to make nice contact between the upper and lower wheel. And on my upper, I'm taking all the slop out of that screw with a couple springs. That's keeping constant pressure up here, so when I adjust it, there's no slop. That'll come down. And I've got a lot of adjustment in here, so you could adjust your wheeling height for different height people. This works out good for me at about 44 inches to the top of the bottom wheel, and that works out nice that way. So I'm going to show you a few different things. I'm going to get some sheet metal out finally here and show you a few different things, and show you why this wheel is so nice. And I'm going to reset the camera for that, and I'll be right back with you. Okay, here's a shot of my lower anvils. This is how I get the material. This is just 3.5 inch diameter S7. My bottom wheels are made out of S7. It's not too terribly expensive in this size, and because I don't have any CNC stuff, I got to do half of the wheel. Bore everything for the bearings and axles, and then flip it around, indicate it again, do the other half. Very, very time consuming. I don't recommend it unless you got a lot of time and you want to make real high quality wheels. There's nothing out there that I really liked, so it was a battle. So my bottom wheels are 3.5 wide, 3.5 diameter. And this first wheel I have is 3.5 inch radius across the top. It's about as tight as I can go. The next one is I wanted that to be an 8 inch radius, but it turned out to be a 9 inch radius, and I left it 9 inch radius. And then finally a 15 inch radius wheel. And with these three wheels you can do, I think about 99% of your shaping. I'm going to make a flat wheel also. Probably out of this guy I'll finish and make a flat wheel. And I've got a few more blanks of S7 that I can make into other wheels, but you don't need 8 or 10 different wheels to do things. It's just these three wheels will get you where you want to be. And I started off thinking I was going to put a 1/2 inch axle in there, but the machine is so powerful that I went with 3/4 inch axle. And we'll get one of these loaded up in the machine, and I'll talk a little bit about the upper wheel and the size I made that one, and then we'll do some wheeling. Okay, here's my upper. That's running on a 1 inch axle, and my lowers and my upper are hardened. It's just how I like to run them. And this is 3 by 9 inch. And there's a bunch of guys out there running massive wheels, 6 inch wide wheels, this and that and the other thing. You just got to do what's right for you. I'm not a fan of a real big wheel. I like this size wheel. Inside here you'll see I have some spacers, and I can run up to a 4 inch wide wheel in here, or I could take this 3 inch wheel, I could offset it, move it in here on the bottom wheel, if I want to try and turn a flange or something like that. I don't do a lot of, you know, flange turning in the wheel, so it's not a big deal for me. But I can fit a 4-inch in there, and I just want to show you when you get a nice hardened wheel. It's got a nice ring to it. That is a super hard wheel, and like I say, the bottoms are hardened as well. You don't have to. I always like the hardened upper. You don't have to harden the lowers. Over time, they'll start to wear a flat in there. It just depends what you like. You either like that or you want them hardened. It's completely up to the guy doing the wheeling. But let me close these wheels up a little bit, and I'll show you the first wheeling that we're going to do, and try and explain how the machine reacts. Okay guys, you remember I'm building some fenders for that snowblower Jeep because I'm unhappy with all the used ones I'm finding. And if you watched the last video or a few before, you see I made a template, a flexible shape pattern. And then I just took that flexible shape pattern, threw it on a piece of sheet metal, and made the sheet metal much bigger than I need. And we know this area has to come way up, and I'm going to shrink this back section here. I'm going to shrink all this section that has to go down that way. I'm going to shrink that in with the power hammer. It's just much faster. But I want to show you a few things on the English wheel. And I don't normally shape by knocking walnuts into the piece and then smoothing them out, but I know it's an easy way to go if you don't have a power hammer or some way to really put shape into a panel real fast. Basically, you just you knock the shape in with a hammer and then you go smooth it out on the English wheel. Not my preferred way, but I'm going to show you the benefit of this particular machine. Okay, I've got a shop bag on the bench, flipping the panel over. And this is a hammer. This is the top of an old oxygen bottle or a gas bottle or something. Welded it to a piece of metal handle. And this is an easy way to knock some shape into a panel. I'll try and stay out of the camera. Okay, I just knocked some walnuts in there, and like I say, this is not normally how I shape. I do this kind of work on the power hammer, and I would shrink all that in on the power hammer, and I'm still going to do that. But I just want to show you how we're on the wheeling machine, how we're going to smooth this out. So let me set up for that, and I'll show you where we're at. Okay, guys, got the panel in here. And you can hear it's kind of jumping around on the lumps we got. It's a big piece. I maybe should have used a smaller piece for demonstration. But we're gonna start rolling these out. And I got the 3.5-inch radius wheel in the machine right now. I've got a very loose setting on it. We just want to knock down those lumps. And we'll just skid around any which way in there. And like I say, we're just going to knock those lumps down. Okay, while we're knocking the lumps down, we don't want this so tight where we're knocking a lump down and then as soon as we hit some other metal, we don't want to stretch it out. That's why we've got a very loose setting here. And when you take the sheet out, A lot of machines, you take the sheet out and the wheels will clap together. This isn't going to do that. You see those wheels, they've got low pressure on there, and the wheels aren't clapping together and making a mess. So we'll creep up on this a little bit. We'll put a little bit of pressure with the upper. And that's going to start to get smooth. And what's happening is it's acting more like a rolling machine right now, where we're just knocking the highs down, but we're not stretching out the lows or anything. We're making a nice a homogeneous panel, basically, is what a lot of guys call it. We don't want to work against ourselves, you know, knocking shape in there. We don't want to take it right back out again. So like I say, you can see the wheels aren't really clapping together. So I'm going to creep up a little bit on pressure and smooth this out, and I'll be right back with you. Okay, I just creeped up a little bit with our bottom adjuster. You can hear it's starting to sound a little smoother. And not really worried about tracking perfectly. This is a very sharp radius, and my bottom wheels have flats on them. So it shapes real fast. But like I say, I'm going to run this in the power hammer to get all this metal to shrink down, and that'll kind of raise that up faster. But I just want to show you what this wheel feels like. And we'll creep up just a little bit more with the bottom. I don't know if you can hear it, but you can kind of hear the pressure I have on there with the wheels kind of making the right kind of sound. You'll hear the right sound when it's happening. So in just a couple minutes we went from all those terrible hammer marks to a nice smooth panel. I'll just wheel a little bit more and we'll take it over to the bench and I'll show you. A little bit more pressure from the upper. Get all the marks out of there. It's almost a big enough panel for two people, but because it's just starting, it doesn't matter if we get any little marks in it. We'll get all that worked out later. But it's almost big enough where there should be somebody on the other side to keep it from flopping. Okay, that looks pretty good. I'm going to take it out and I'll meet you back over at the bench. Okay guys, that was just a couple minutes on the wheeling machine, and we've got all our walnuts out of there, if you will. I went real quick with that sharp wheel there, so I got a few little wheel tracks in there. But like I say, we're gonna hit all this in the power hammer and bring it down. But you can see how fast that'll start to raise an area, knocking around with the hammer, smooth it out with the wheel, and it does a nice job. I'm going to move over to the hammer right now and bring some shrinks in here to this black line, and I'll show you how quick that will start to fold over. So it's kind of nice. Some guys don't have both. Some guys like hammers, some guys like wheels. I like both of them. The English wheel I'm primarily going to use for door skins and low crown panels. I just want to show you how nice it'll take hammer marks out of there. But I've made some Willys FC 150 and 170 door skins, and they're coming out super nice with the wheel and various other parts and other low crown panels. But I'm going to jump back to the power hammer and show you how fast we can shrink that in. Okay, the idea with the shrinking is we're gonna get this metal to come down like this. That was just a couple passes in there. When this comes down, this is gonna appear to be higher. This will be down. And I still got a lot of work to do on that. I just want to show you the techniques I'm going to use to make this inner fender. And here's our piece. And you can see when this comes down, this will stick up and start to fill our pattern a little bit better. But like I say, it's an oversized piece. It's a little awkward to handle on the hammer. But as it starts taking shape, we can start trimming it and stuff. There needs to be a flange there and over there. So we got to leave plenty of room for flanges. But between the power hammer and the English wheel, we'll get this whole section raised up. You can see how simple that would have been to make with a stamping press. It would be one smack and you'd have the inner fender. It's going to take quite a bit of shaping to get that much shape in the panel. And I'm not going to bore you with just watching the hammer or the wheel go. But this will start coming down this way. This will start getting raised up, and I'll bang this out a little bit with the hammer to get it raised up. Keep shrinking this down, and pretty soon we'll have our major shape in here, and then we can fuss around with all the other little stuff, bending it and moving it in the right direction. But this is the main area of stretching and shrinking that I'm doing. So those are the techniques I'm going to use. Shrink it down, raise it up, shrink it down, raise it up. Okay guys, a few more tips about this wheel. If you have your panel all finished and you just kind of want to wash over it, get all the tension out of it, these upper adjusters here on the blades, by loosening or tightening that, you could give the wheel a very, very soft feel. You won't be putting any tracks in it from your wheels or anything like that. Or if you're just starting your panel and you want to put a lot of shape into it fast, you tighten up that guy and that guy. Get it so that the frame is nice and rigid. Put some tension on your upper. And I've just got a little piece of metal right here, and I've just spent a couple minutes on it. And it'll throw shape in real fast. There's a lot of tension on the wheel here. And that's my 3.5 inch lower. And it's got about a 1/2 inch, maybe 3/8 a 1/2 inch flat that I milled in there because I don't like true radiuses. I like to have a little flat there. I just like to shape that way. I don't like true radius. Power hammer dies, and I don't like true radius dies of any sort. And that's just how I shape. But you can run true radiuses. But this is putting a lot of shape in this real fast. You can feel it in your hands. You could feel the metal stretching both ways. And it will leave some marks. But again, it's steel. And it'll be a lot more work on a panel like this if you were making something. And you could easily get the wheeling marks out of there. I'm not tracking real close. But you could see in just a few minutes you can get a smooth panel with a lot of shape in it. I just used a small scrap out of the scrap bin, but you can almost see the reflection in it already. It's moving a lot of metal, and it's moving it fast, and you can see the shape that goes in there. And I've been fortunate in the past, over the past, let's say 30 years, I've had a lot of different wheels. I've had cast wheels, Edwards wheels, you name it. And some cast wheels are super rigid, up and down this way, but they're real flimsy this way and this way. And there's a million different fabricated wheels out there. And I searched for a long time. I wasn't just going to try and make a wheel just, out of my head. And I couldn't have done it without Kirk, his design there. And like I say, he spent 15 years perfecting this design. You can't just go and throw a bunch of steel together and think you're going to hit it right the first time. The dimensions on the blades and the pressure points are critical. But this is a very nice wheel. It'll do just about any kind of shaping you want. There's a, I think that's 34-inch throat on there. I didn't want to go any bigger. There's a lot of 44-inch wheels out there, but that's a very big piece of metal to put through a wheeling machine. 34 inches works for just about everything I do, and I'm super happy with it. And if anybody needs any more information on it, just send me a comment, and we can talk about it. So that's all I have for you today. I didn't get real far on the inner fender because I wanted to show you a few different things here about the wheel. But on the next one I'll have more done and show you different stuff, how I got to the shape. And that's all I have for you for today. And as always, thanks for watching. And if you like the video, hit the like button, subscribe, tell a friend. Like I say, I'm always trying to make the channel better, so if there's anything you'd like to see, just shoot me a comment. Otherwise, I'll catch you on the next video.